Okay. So number 3 says 2 different professors teach an introductory statistics course. The table below shows the distribution of final grades they reported. We wonder whether one of these professors is an easier grader or whether their proportions are the same. Okay, so this is, and the final chi-squared test, chi-square, this is what I gave out yesterday, the handout. Test for homogeneity. Notes through this problem. So homogeneity, the chi-squared test for homogeneity. Now, you need another copy, Kendra? Okay, now this test is used when you have a single categorical variable from 2 populations. And it is used to determine whether the counts or the frequencies or the values are the same or not. So, single categorical variable, in this case the categorical variable is grades, A, B, C, D, F, from 2 populations, Professor A, Professor B. And we're comparing, are the grading the same, or is one harder or easier than the other? So step 1 is name the test. Okay, we did that. Step 2 is hypothesis. So the null is that the proportion of A's, B's, C's, D's, and F's are the same for both profs. Shamar?
Is that going to be the percentage for all?
The null for all? Anytime you have a homogeneous, it's going to be like the proportion of like satisfied and not satisfied is the same for men and women, or the of whatever.
The sample is the same for both groups.
Yeah. And the alternative is at least one proportion, at least one proportion stated in the null hypothesis is false. So at least one of the proportions in here is false. So step 1, name the test, hypothesis. Step 2, conditions. So again, there are the 4 conditions we have. And so what are the conditions? First, we have a random sample. We have a random sample. And here, we sampled everybody in their 2 classes. Right? So random sample, bless you, is important so that we have a chance of getting, that the chance of picking Eddie equals a chance of picking Dex. If I pick everybody, random, a little bit less important because I'm sampling every single person. So random sample Victoria Taylor has it. Because each student's grade is used. Number 2, population. We assume there are more than 2 classes at the school. Sorry, more than 20. So we sampled 2 professors' classes. We assume there's more than 10 times 2, 20. 10 times 2 equals 20. Say it again, sorry.
So you said the population is 2 times sample.
This one is, what I said in the random sample is wrong, but keep going.
But you said like it's 10 times 2.
Right.
Shouldn't it be like 10 times however many number of students there are?
Shouldn't it be 10 times however many number of students there are? I am sampling 2 classes. Shouldn't it be 10 times however many students there are? My sample size. No. So the sample is I'm taking the 2 classes and okay. Would it your answer would you would agree with me that the sample size was 2 if I was, let me see how to best explain this. I am examining the 2 classes and comparing what happens in class A with what happens in class B. So I'm comparing results from A with results from B. Does that work? So,
Could you say it like that? The results are the grades.
The results are the grades, I agree.
And then multiply the number of users.
But there are only 2. Oh, okay, yeah, let's say it this way. Yeah. So because a chi-squared test for homogeneity looks at one categorical variable, the grades, among 2 different populations. And the populations are class A and class B. So because we have those 2 populations for every chi-squared test for homogeneity, we're comparing 2 groups. We assume that it's sample size 2. That's a good way of saying it tomorrow. Good job. Okay. 3. The variable is categorical, but that's a really good question, Alex. And number 4, each cell count for expected, or each expected cell count, if you want, is greater than or equal to 5. And again, you want to write, see the table below. So the 4 conditions. So the next step is the math. So on the math, you can just quickly calculate degrees of freedom, which, as we said, was rows minus 1 times column minus 1. So how many rows are there? There's A, B, C, D, F. So 5 different rows. And there are 2 columns, class A, class B. So this is equal to 4 times 1, which equals 4. Now you go to the calculator, and you're going to type this data into matrix. So this will be new for Alex. I will review for everybody else. Again, we'll start with the Inspire.
How do I?
Put it up, brightness.
Yeah.
Ah, good call, guys. Okay, so we go to new document. No, I don't want to save. I add calculator. And now remember, we need to put the data in as a matrix. So remember, matrix was under menu. So Alex, menu number 7. And then number 1, create. And then number 1, matrix. So 711. And how many rows and columns are in the matrix? Well, there are 5 rows and 2 columns. Then click enter and you should have like the matrix pop up. And of course this is maybe too bright now. There we are. So now you just plug the data in. So in the first column we have 3. Then we have a 9 over there. Then 11, 12, 14, 8, 9, 2, 3, 1, and click enter. And the matrix should pop up on the right. You got Alex before? And then we have to click control var, and remember var is right above the 9. So you do control var, and that is to store. And it should come answer with the arrow. And then you want to store this as either O for observed, or some of you just want to put A, it's fine. You can put anything you want, just a name that you'll remember. So I'll use O for observed. So now I told the calculator, okay, this is the stored this matrix as observed. Anybody on Inspire not sure how to get up to here? Okay, and now you actually do the test. So you go menu. Now you got to do the test. So statistics number 6, stat test number 7, and then number 8, chi-squared two-way test. We should get this screen. And then you want to just click the right arrow, and it should pop up with whatever matrix you called it. Just click enter, and click enter again, and you should have the chi-squared and the p-value. Okay, Inspire, any questions on that piece? Okay, so Inspire, folks, let's go ahead and write this down, draw the picture, color in the area, write the conclusion. So Inspire, we're good. 83, 84, let's model. So 83, 84, I'm going to go second matrix. I'm going to go edit. And I want to go a 5 by 2. And I get the new matrix here. And now I punch in the data. Okay, anybody on 8384 not punched in the data? Frida, you good with the data punching in? Eddie? Shunli? Okay, now remember we go stat, we go over to our tests, and we go to chi-squared two-way, so we go chi-squared test letter C. Frida, you got that? EP3, letter C, Shunli? Okay, Norma, you good? Okay, then observed was A. This will automatically calculate for B, and then just click calculate. Did you guys get the chi-squared as a 9.36 and the p-value 0.052? EP, you did not get that. Okay. Other folks got that? So everybody's drawing the picture, writing the sentence. Remember, you need to copy down the expected matrix. I'll show you how to do that. Oh, you put it in E? Okay, that's fine. So then when you go to E, you know what I'm saying?
Yeah.
Okay. Remember, guys, we have to copy down the expected matrix. So how do we do that? So I would write over here expected. The expected, and I'd make a little table. And I'd write like A, B, C, D, and F. This is the expected, and then I would be like Prof A and Prof B, and I would tell them from the calculator. And again, the reason you're writing this down is to prove that the expected counts were bigger than 5. So how do you do this? On the Inspire, we put the calculator on, and then we go to, just go ahead and click var. And one of them should be stat exp matrix. If you click var, stat exp matrix, just click enter. And then just click enter again, and it should pop up with this expected. Inspire folks, are we getting this? Expected matrix, 6.666. And then you need to copy that down. Okay, 83, 84 folks, remember, it automatically makes it matrix B. So how do we do that? We go second matrix, scroll over to edit, come down to B, and there it is. All right, so 6.667, 12.777, 12.222, 6.111, 2.222. Okay, so you got this down for expected. All right. Now we need to actually show them what is the chi-squared. So we need to come over here and write chi-squared equals sigma observed minus expected squared over expected. Tell them you know what the formula is. And then I agreed with Brian yesterday that it is unnecessary to write this in a real world situation. Of course, the AP exam wants you to do what I'm about to do, so let's just get in the habit of doing it. It takes another 3 minutes. Remember, you can't leave the AP early, so it doesn't matter if you finish early. Still have to sit there. What happened? So, here we go. The chi-squared equals the observed. The first thing we observed was a 3. So 3 minus 6.667 squared over 6.667. Plus, the next thing we observed was 11, right? I'm just going, the observed are just what we actually got. And I know this is a pain, folks, but let's just get in the habit of doing it. Mm-hmm. Plus, the next thing we observed was a 14.
Are we doing this 10 times?
In this case, yes, we are doing it 10 times. And I'm not going to write it every time. On the exam, of course, you need to. Usually, it won't be this bad, though. Like, there won't be this many categories. But the key is you want to end up by saying the chi-square. And you might be able to get away by putting plus ... You might be able to get away by doing that. But the key is to tell them what does the chi-squared actually equal. Well, in this case, it equals 9.361. And the p-val, these are actually what's super crucial. P-val is 0.05. 268. Remember, just 3 decimals after the zeros. So 0.526, draw the picture. So remember, we come up, we got the long tail, this is right skewed. Somewhere over here, just randomly pick 9.361. Nobody's going to hold you to it being exact. 0.0526. And the sentence, since the p-value is bigger than alpha, we fail to reject the null hypothesis, and we conclude that the proportion of grades are the same, or we conclude that one professor is not easier than the other, however you want to say it. Do I need to write that? I do? Okay. No problem. Since p-value of 0.0526 is greater than 0.05, the significance level, we fail to reject and we conclude the proportion of grades or the distribution of grades are the same, the proportion of grades are the same, and one professor is not easier than the other. One more time for me, Brett.
Can we just say that we accept and then like,
No. Fail to reject. Crucial. Okay. So, let me stop here. And that is it before the CA. So here's the plan. The plan is